Hi everyone, in this video I'll be going through chapter 11 worksheet 2, the last part of this worksheet, example number 6. Okay, so let's look at example number 6 directly, which is where I stopped previously. Alright, let's look at example 6 now. Find the values of z between 0 and 8 for which 16 sine z over 2 minus half equals to 15. So I'm supposed to solve this equation here and find this value of z, which is an angle. And you notice if this condition here, values of x between 0 and 8, meaning that z is between 0 and 8, not inclusive of them. And if we note, usually the question usually states either degree or radian. Even though here is 0 and 8, I hope we can tell that this, because there is no angle here or no degree, therefore we can imply that this question, z is in radian measure. Okay, so over here, as what we have done in the previous examples, I have 16 sine z over 2 minus 1 equals to 15. To make life easier, let's simplify this by rewriting this z over 2 minus 1. Okay, I'll let a be equals to z over 2 minus 1. So therefore from here, this means that 16 sine a is equal to 15. Over here, that means if I make sine the subject, sine a is equal to 15 over 16. Okay, then from here, now my next step is to identify the quadrant. By drawing the ASTC diagram, I can see that over here, ASTC, sign is positive, it means it lies in the first quadrant and second quadrant. So therefore, A lies in first and second quadrant. Okay, second quadrant. So therefore, next step is to find the reference angle, alpha, is equal to sine inverse 15 over 16. Okay, therefore press in your calculator. Remember to make sure your calculator is in radian mode when you calculate this. Okay, and if you press, since now my angles are in radian, I leave it to 5 SF. This will be 1.2153 radian. Okay, this is in 5 SF. Okay, therefore from here, this means that A is equal to first quadrant, it will be 1.2153, and in the second quadrant it will be pi minus 1.2153. And since I know that the range of values for A, okay, over here I start from what I'm given is 0 and 8. Z is between 0 and 8, which means that over here Z over 2 is between 0 and 4, which means that z over 2 minus 1 is between negative 1 and 3. Okay, so that means that in this value here, A should be between negative 1 and 3. Okay, this, why do I need to do this is because I want to check what is the condition, what are the range of values for A that will satisfy the original inequality given to us. Okay, so over here I can check if I were to, my values of A here is indeed between negative 1 and 3. If I add 2 pi or I minus 2 pi, all the other additional answers are out of the range already. So therefore for this question, I just need to consider these two answers over here. There's no need to add or subtract any cycles to find more solutions for A. Okay, now I can replace back A with z over 2 minus 1 equals to 1.2153, comma, and 1.9263. Okay, therefore z is simply, I add 1 to these two terms over here, and then I multiply by 2. So therefore, if I were to calculate this, round this off to 3SF, your answer would be 4.95 radian and 5.85 radian. Okay, I'll leave my final answer here, right? The units, radian, RAD, and I said that I'm rounding off my answers to 3SF. Alright, so that's the answer to this example number 6 over here. Okay, so now I'll work through the one simple practice questions, and then you can go back and complete the assignment questions as homework. Let's look at the practice question from your textbook. One simple practice question here. Okay, solve the equation cosine 3x equals to 0.5 for this range of x between negative pi and 2 pi. So what do I need to do? Very simply, I write out my equation here first. Cosine 3x equals to 0.5. First step, once this cosine is the subject of the equation, coefficient is 1, Okay, I shall now identify the quadrant. Cosine is positive. It means that my angle lies in the first quadrant and fourth quadrant. Okay, so therefore this means that in this case over here is 3x. You can also replace this by a. If not, you can also just use 3x. This means that 3x lies in first or fourth quadrant. Okay. Therefore, from here, next step, okay, I would now find a reference angle. Okay, reference angle in this case, okay, is simply alpha equals to cosine inverse 0.5. Okay, so as you know, cosine inverse 0.5, this is a special angle. Cosine inverse 0.5, this question is in radian measure. So cosine inverse 0.5 is actually 60 degrees or pi over 3. Remember again, if question is in radian measure, your working should all be in radian. I should not see a degree over here. Okay, so therefore this means that once I get the reference angle, I can now write, therefore this means that 3x is equal to, first quadrant it will just be pi over 3, second quadrant it will be, fourth quadrant it will be 2 pi minus pi over 3. Okay, however, this range here, okay, I know that the question once told us that x is between this range, but over here I have 3x. So this means that I have to update the range. Range is simply 3x is between negative 3 pi and 6 pi. So this means that from here, I can continue finding more solutions that will fit within the range of 3x lying between negative 3 pi and 6 pi. So this means over here, if I can find more solutions, I add one cycle, it's 2 pi, I'll get 2 pi plus pi over 3, still within the range of less than 6 pi. Okay, I can continue getting 2 pi to the next solution here, add 2 pi plus 2 pi, one cycle, I'll get another solution, 4 pi minus pi over 3, still within the range. I can continue again, add another 2 pi plus 2 pi, I will get 4 pi plus pi over 3, still within the range of, still within the range of less than 6 pi. I can continue adding again even further. Okay, one more, which is from 4 pi here, I can add another solution plus 2 pi, I'll get another solution, 6 pi minus pi over 3, still within the range of less than 6 pi. Alright, now I can work backwards. Okay, I can, instead of now adding, I can also now subtract. Okay, so over here, next solution. Okay, over here I can get, let's work out the next solution. Let me write, maybe over here. From here, okay, I can minus away 2 pi. I have another solution which is pi over 3 minus away 2 pi. Okay, still within the range. Next solution here, 2 pi minus pi over 3, I can also minus away 2 pi. I will get negative pi over 3. Okay, and still within the range. We check again. Any other solutions do I have that is still within the range here? Okay, let me see. 2 pi over 3 minus pi, negative pi over 3. Okay, and okay, I have one more solution actually. I can minus away 2 pi here. This will give me negative 2 pi minus pi over 3. And this is still within the range. Okay, over here if I minus away 2 pi, it will be out of the range already. Okay, so therefore I will have 1, 2, 3, 4, 5, 6, 7, 8, 9 solutions to this question. Therefore I can simplify it step by step. Okay, we simplify all these different expressions. I will have pi over 3, I write in order, so this will be pi over 3, 5 pi over 3, 7 pi over 3, 11 pi over 3, okay, 13 pi over 3, 17 pi over 3. Then I evaluate the ones at the bottom. This is negative, over here negative 5 pi over 3, negative pi over 3, and negative 7 pi over 3. Okay? Therefore, to find, the question is solve the equation. I want to find x, not 3x. Therefore, final answer, I divide by 3 to everything over here. Final answer is simply x is equal to pi over 9, 5 pi over 9, 7 pi over 9, 11 pi over 9, 13 pi over 9, 17 pi over 9, negative pi over 9, negative 5 pi over 9, and negative 7 pi over 9. And with that, we have the solution to this question. Okay, so you may notice it is not easy to find what are the solutions that are within this range. So it requires you to be very aware of what is the range of what you are finding. Therefore, you check by adding cycles, adding or subtracting cycles, how can I find more solutions that will lie within the range given in the question here? Okay, and with that, this is the practice questions. I hope you can understand this, and now you can start on the homework questions assigned to you. Okay, this is the end of the video.